Hello, and welcome to solving logarithmic equations. This will be an intermediate algebra approach, which basically means they just work out better than some of the later examples that you'll see in college algebra or pre-calculus. Okay, so in order to solve logarithmic equations, 4 steps, once again. Isolate. Whether you're solving absolute values, you're solving exponentials, you're solving using the square root property, we always start by isolating whatever type of function we're looking at on one side of the equation. So we get all the logarithms on one side. Then we'll combine the logarithms into a single logarithm if necessary using our product, quotient, and power rules. And then we'll rewrite in in exponential form, solve the equation by isolating the variable. So really, it comes down to this step right here. Just like we did in solving exponentials using logarithms, in order to solve logarithms, we'll use exponentials. So we're going to go back and forth in this form quite frequently. All right, let's start on this first one. So there's only one logarithm. That's fantastic. It's already isolated. It's already a single log. So let me just isolate. Yep. Combine. It's already done. So let's rewrite. Now if there's not a base written, it's assumed to be base 10. The log is the exponent, so the 3 is the exponent on the power of 10 in order to get x minus 10. Well, 10 to the third is a 1 with 3 zeros. All right, 10 times 10 is 100. Multiply by another 10, we'll get 1,000. We could solve 1,000 equals x minus 10. Let's add 10 to both sides. We get x equals 1,010. That's it. It could be that easy. And if it is that easy for you, run with it, let it. That's awesome. So it's already isolated. It's already combined into a single logarithm. The base is 10. If it's unwritten, it's assumed to be 10. So it's 10 to the power of 2 because the logarithm equals the exponent. 10 to the power of 2 equals x plus 4. 10 squared is 100. If we subtract 4 from both sides, we get x equals 96. And we could always check this if we wanted to. We could do log of 96 plus 4, 2. And because we know 96 plus 4 is 100, we know that 2 is the power we put on 10 in order to get 100. Right? We know logarithms. Logarithms are just exponents. Nothing hard about it at all. Don't overthink a logarithm. It's just a fancy way of writing an exponent. Now in this problem we have 2 options. So I'm going to break them up. First instinct over here. And my first instinct says, hey look, if the log base 10 of x equals the log base 10 of 5, I'm finished using the one-to-one property of logarithms. But what if I don't notice that at first? What if that's not just something that occurs to me? What if I don't really see myself as a mathy person and I just want to follow the procedures so I could learn this? What's going on then? Well, we can get them on isolate. Let's try to think of the word. We have log of x minus log of 5 equals 0. We got all the logs on the same side. We could combine. If you're subtracting 2 logarithms of the same base, you divide their arguments. The inside of a logarithm is called the argument. Combine, now we rewrite. And we know that 10 to the power of 0 equals x over 5. All right, base of 10, because it's unwritten, so it has to be 10 to the power of 0 equals x over 5. And then to solve, 1 equals x over 5. Let's multiply both sides of this by 5. And we end up with x equals 5 either way. Let me see if I can make this look good. All right. So if you recognize the one-to-one property of equality of logarithms, then fantastic, you're done. It's all good. But if you don't recognize that, these steps still work. These steps work for every single logarithmic equation that you're going to see in an intermediate algebra class. Every single time. So you can trust these. Isolate, combine, rewrite, solve. If I was taking a test, I would probably have this on a note card. How do I solve logarithms? Isolate, combine, rewrite, and solve. And if you write this down as you do your homework for each problem, you won't need an example on that note card. All you need is, oh yeah, isolate, combine. Whoop. Yeah, rewrite and solve. I forgot my steps. Okay. Now these ones, this is going to have a little more work. We're still at base 10, so that's good. The isolated is done. All the logarithms are on the same side. So we're going to combine. To combine these logarithms, remember if you're adding two logarithms, then you multiply their arguments. So log of 2x times 3x, this is, I'm going to throw in a simplify step. That's log of 6x squared equals 3. We're going to rewrite in exponential form. This is 10 to the third power, right? Base of 10. Log is an exponent, so the 3 is the exponent, equals 6x squared. And then let's finish it. 10 to the third power is 1,000. Let's divide both sides by 6. And finally, we will take the square root of both sides. When we take the square root, we should always consider the plus or minus. However, the domain says the argument has to be greater than 0. Right? The domain of a logarithm is non-negative. We know that because we know what the graph looks like, right? It's the same as the range of an exponential function. And so this is telling us in both cases that x has to be 0. So if you forget about the plus and minus in this one, it'll be okay because we ignore the negative one anyway. Now this is our exact answer. We probably should simplify that radical a little bit. 1,000 divided by 6 is nothing good. And when we take the square root of that, we get a decimal. Let's round this to 3 decimal places. That 9 there is going to take me up to 12 point, what comes after 09? 10. So make sure you put that third decimal place even though it's a 0. I'm going to do a slow scroll. I'm going to see what our instructions say. It just says solve. It doesn't tell us to round at all. So I probably should have simplified the square root. We'll look at that kind of thing later. That's in a future video. Last example of this type. It's the only one that has a different base. All right, so we isolate. Already done. We combine. Already done. We rewrite. The base of the logarithm is 3. The log equals the exponent, so 4 is the exponent that I put on 3 in order to get 3x plus 5. And finally, I solve. So 3 to the power of 4, I'm pretty sure that's 81, but let's check it out. Just make sure you're with me here. 81 equals 3x plus 5, and this is what we started the semester on. This one you all know how to do, so let's not do something crazy and stop writing our details. Let's write it out so we don't get too excited about a problem we can recognize. Subtract 5 from both sides. 81 minus 5 is 76. If 76 equals 3x, we'll divide by 3. This is a great exact answer. Let it be a fraction. We don't care what that mixed number is. Mixed numbers should only be used for carpentry and baking. That's it. We don't use mixed numbers for anything else I could think of in the real world. Which is weird because we spend so much time teaching you mixed numbers when it comes to schooling. We don't use them in the real world. Leave it as a fraction. If you want to know what 76 divided by 3 is, that's 25.333. So my approximation would be the decimal. All right, so what you put into the calculator is your exact answer. What you get out of the calculator is your approximation. If it doesn't ask for decimals on the homework, you don't even grab the calculator. You just enter that answer and everything should be groovy. All right, you heard my dog moan in the background. He's thinking it's breakfast time, but he's wrong. He'll wait until we do another video. Thanks for listening.